today. It's about ball devices and ball tracking in the Mission Pinball framework. We got an agenda again, and our agenda is first we will talk about ball tracking. So what is that? Why do we need it, and what does it do? Then what are ball devices in general? What do they do? How do they do it? And especially how does like the eject sequence work? So how does it get a ball from like your trough into your shooter lane, for example? And that's all still like relatively simple, but it gets more complicated if like 5 devices are involved and you stage balls somewhere with diverters and stuff. But the theory is always the same. So those ball devices all behave the same. It's the same code. And yeah, I will explain how that works and how this sequence works. It's important to understand. Then we will go into like ball counting. So how does the ball device know how many balls it has and what does it do there? Because that's, yeah, I guess that's maybe not the complexest part, but it's a complex part, I would say. So low. Yeah, then we will go into ball ejector. So the ball ejector is the part which actually makes sure the ball actually leaves the ball device when MPF or like the player wants it. And there are like also different ways how this can be done. And there are multiple implementations in MPF, and we will look into those. And at the end, we will talk a little bit about how you can improve the reliability of your like ball devices or ball tracking in general. Because there are, I wouldn't say those are pitfalls, but there are stuff which is not like auto-detected, which you can configure, and you should configure it in most machines, in my opinion. Totally makes sense. So let's get started with that. So what's ball tracking? So ball tracking in the Mission Pinball framework is the basic questions: where are the balls? So typically you know that you put like 5 balls into the machine, but if you come back like 5 days later, you don't know where they are, or maybe one ball got loose and I don't know, fell through the playfield into the cabinet, for example, stuff like that, right? And MPF needs to make sure that it knows where balls are, at which device they are, at the trough, at the launcher, at the scoop, at some like ball lock, for example. It needs to know. And then there can also be balls on the playfield. So that's important, right? Because you cannot, for example, start a game when there's still balls rolling on the playfield. So, for example, if a game ends, typically all balls are ejected, for example, from any ball locks, and you cannot start the next game before all balls drained. And for that reason, it's also important to like track balls on the playfield. And I mean, yeah, during the game, obviously, it's also important to know that for example, running a multi-ball, because then you need to know how many balls are on the playfield. Additionally, there's like balls in play. It's different. So balls, like where balls are, is like ball tracking in MPF. That's like the job of the ball controller, how it's called. And the ball controller will make sure that it knows where balls are, and also that it knows how many balls exist in total. And that's often important. So, for example, if there's only one ball out and it goes into some device, then we can ensure that there's no ball anymore on the playfield. And right. So exactly, you don't want to start games if balls are somewhere and you don't know where they are. And like even if you know that all balls which are in play are in some ball device and there's none on the playfield, and the ball device ejects to the playfield and it hits any playfield switch, then we know that this ball actually made it to the playfield. And that's not valid if there's another ball in play, right? So then it might be another ball which hit the switch, for example. And for that reason, we also need to know how many balls exist, right? Usually this number shouldn't change during the game. So it can change when like ball search misses a ball because, I don't know, it got stuck behind some post, or you know that, right? Crazy things can happen. Balls can end up everywhere, and they will eventually. So it might be possible that the ball gets lost, and then ball search will remove it from play, and will also reduce the number of balls known. Similarly, there could be another ball which becomes available during game. For example, it got stuck before and it becomes loose. That's a scenario where we say, well, that's unlikely that this happens. And in that case, your game will likely break anyway, because like you got like random drains for this additional balls, so stuff will break. And for that reason, MPF does not account for that. So we ignore that possibility. So if we got like a trade-off, is this a new ball, is this an existing ball? During game, we say it's an existing ball, we are certain. We do not like consider this possibility because it's all lost in this case. The other way around, like with ball search where ball got loose, we try to do our best to make the game somehow continue. And that's just important to know. But like in reality, that's also rare that the ball just like comes loose from where it got stuck, right? If ball search didn't get it out, then it's usually something for the operator to open the glass and get the ball out. So that's at least our take on that. Yeah, and balls in play is generally tracked in the game. So the game tracks balls in play. It's very simple. It has, eject a new ball, increment balls in play by 1. Then multi-ball does exactly the same. Then multi-ball has a drain handler, and when the ball drains, it reduces balls in play. So that's relatively simple and basically independent of ball tracking. That's just important to just keep in your mind that this exists. And this generally works in MPF. We are rarely losing track of balls. So usually it's like stuck switches or something. Then stuff might get bad, but not in normal games with normal game flow. That leads us to ball devices. So where are our boards? So there are ball devices in MPF. And we got a nice graph here. I will explain it in a minute. So the first responsibility of ball device is to count balls. So it needs to know how many balls are in there. It sounds trivial, but it isn't. So for example, if you look at like Gottlieb, those old Gottlieb troughs, they got like less switches than balls. So they got like a switch on position 3 and position 1, and they left out position 2. So if the first switch is active, there might be either 1 or 2 balls in the trough. You cannot know. And like if the third one is active, then you know that there are 3 in there. I mean, theoretically, there could be even 4. You don't know, right? So it's also like always a possibility in ball devices that there's like an additional ball just sitting behind all the balls, and you will never know because there's no switch. So in some machines, like for example in my head-to-head machine, where there are more balls than fit in one of the troughs, that's actually an issue. So there we have to account for that. Generally, MPF doesn't, right? It's not an issue in most machines, but it can be. But like that's the responsibility here. So it needs to know if it knows that the count is correct, right? So the ball device needs to know, well, I'm certain at the moment or I'm uncertain. So that's something it has to know, right? Then it has to eject balls, at least most of the devices. So the plunger, if it's only a manual plunger, it's the only like ball device which cannot eject balls on its own, right? So you plung it, then the ball gets out, but the machine or the software cannot force you to do it. But for any other device, you typically got like some eject coil, and that coil will like shoot balls out of the device somehow, or some other mechanism. So it doesn't have to be a coil. Then like the task of this ball device is to track and order ball ejects. Okay, the R is missing there. It's like order ball devices and ball ejects. So like ordering means, so first, if the ball device ejects a ball, it needs to make sure that this ball either reaches the other device, the target device or the target playfield, or it returns. It's not possible that both happens, and it's also not possible that none of it happens, right? Because then we would lose track of the ball. So there are like cases where we are not sure or not certain. In those cases, they're typically like timeouts. And when a timeout occurs, we got like a default location, which is typically the playfield. So we lost the ball somewhere between devices. Okay, let's assume it went to the playfield. And if we are wrong, ball search will figure it out. So that's the general strategy there. And overall, like a ball device is a state machine. So that's like what you see on the right. That's not 100% accurate. There's a little bit more than that, but that's like a good mental picture to have that. So the ball device starts like in state invalid, that's like internal stuff, and then it instantly goes to idle. So from invalid to idle is basically where we initially count the balls. So once it initially counted, like all switches were initialized in MPF, then it knows like, yeah, I got like 3 balls, and it's in idle state. And from there, it can either go to like wait for eject. So when like, it gets an eject request, and there need to be some preconditions. We will talk about that next. And after those were met, it will go into the ejecting state. And from there, either the ball leaves, right? It's left. Then we track the ball, or it can fail to eject the ball. So we tell the device pulls the coil, but nothing happens. Maybe the coil is broken. I don't know. Maybe there's something in front of the device. Maybe high voltage is off. MPF sometimes cannot know. So that can also happen. And then there's like an eject broken state, which you can configure to make sure that it doesn't retry for like hours. So you can retry 10 times, and if the ball didn't go out the 10 ejects, then leave it be and turn off the machine. That's something you can configure. It's a decision. Like Stern, for example, as I know, they just try forever. But that's something up to you. When the ball left, it can either like be confirmed by the target device. So like it goes to the plunger switch becomes active, then we know that it made it to the plunger. It's easy. But there can also be like a failed confirm. So we got a timeout, that's the eject timeout, which you typically configure. And if that's reached, we can, so we do not know where it went. So timeout is reached, it didn't reach the target. And there we can either like some point we go into lost balls, so that's when we don't know, and then we put it to the default location, typically playfield, or we can have like a failed eject, and then the ball might return. So typically you eject and the ball returns, but it's different. Like you eject the ball, it doesn't reach the target, you wait 10 seconds, and in the meantime, you got like an additional ball on your device. I mean, you do not know if this ball drained from the playfield, if it's a trough, for example, or if it returned in most cases. There are some cases where you can tell, but generally you can't. And that's basically the case where eject failed, and we would then retry, typically. When it's confirmed, then we typically go back to idle. You can also go from eject confirm to lost balls if, for example, you ejected and you lost like 2 balls. And then like, you wanted to eject 1, but you lost 2. I mean, you can imagine that in a normal trough where you got stacked balls, like a jammed ball on top and a ball on the bottom, and we eject both. That can happen. And then we lost the ball. And typically the plunger will have 2, but the plunger doesn't know because it has only 1 switch. So that's also the same thing. We will then account that to the playfield because we do not know. It's just To us, it's unknown technically. So we watch all the sensors after an eject to see if anything got triggered. Like we look at the target devices. So a ball device has a target, and we will check that target, and we will check the switches of this ball device. That's what we typically check. There are like heuristics, right? So there are like cases where, for example, you got a trough, you got a plunger, and then you got a third device, and the plunger goes into the device. Now it's possible that you eject the ball, and the player instantly plunks the ball into the next device, and we got like heuristics to detect those cases, for example. The target of a bumper. A bumper is not a ball device, so maybe I should define that. A ball device is a device which can actually capture a ball and keep a ball and can decide if it wants to eject the ball or not. So that's a ball device. I mean, the plunger is a little bit special because the player decides, but it has to have a ball switch somehow to be able to count balls and has to capture balls. So like a vertical up kicker, a trough, plunger, any ball locks, and so those are typically ball devices. A bumper simply is not a ball device, or target is also not a ball device. Slingshots are not, flipper fingers are not. It's more like devices which can capture a ball. So those actually, this state machine makes sense. I mean, for bumper it doesn't make sense, I guess. Yeah. So additionally, like there's this mechanical eject stuff. So theoretically, you could stage a ball into a plunger, and we do not want to go to the playfield, but the player makes it go to the playfield, for example, and then we have to special handle that. There's also like a little bit more special handling for mechanical eject, where like the player can mess with your stuff. So, and that's also sometimes very, 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 very tricky, because for example, in a normal machine, what can happen is the trough ejects a ball, the player plunks it without it hitting the switch once, the plunger switch, goes to the playfield, doesn't hit any switches, and drains. That looks exactly the same way as if it just returned to the trough. That's indistinguishable from like this limited machine view, because that only sees the switches. And cases like that are possible with mechanical eject stuff. So it's often a good idea to have some switch on the playfield which is most of the time hit by the plunger. Or you have to tune the timeouts and accordingly so that this works. So it's like, there's like, if you think like a machine, right, you only see the switch hits, then sometimes this isn't as obvious as a human, right? As a human, you say, yeah, it's obvious it went this way and it's there. But as a machine, sometimes that's not decidable. And then you have to use heuristics to decide where you account it for. So that's what MPF does. And you can also like tune those decisions a little bit by certain timeouts and certain factors. Yeah. So that's the general like sequence there. Yeah, like, okay, that's ball search. So yeah, like Williams machines, or like most machines, will, when they miss a ball, so actually it went to the playfield and it didn't hit the switch for like 30 seconds or something, or 20-30 seconds. It's not much actually. Then the machine thinks it's stuck somewhere. So that's technically that's tracked as a ball on a playfield, but now the playfield misses its ball basically, and then ball search will trigger. And that's something which then, in MPF it will also like pulse all the coils. It sometimes will like reset drop targets. If they can knock down again, right, they will restore their state afterwards. Sometimes you can't. Also for ball devices, MPF will, for example, fire coils from ball devices which are empty. So if there's a trough that doesn't have balls, MPF will fire the coil during ball search. If it has balls, it will not. at least not in the first round of ball search. In later rounds, at some point it will also start to eject all balls from all ball devices to find the ball, right? So that's ball search. That's like a different sequence. We will touch the topic a little bit later, but it's like secondary to the ball tracking itself. That's basically what we do when when ball tracking went wrong or the ball got stuck somewhere. I mean, it's physics and it happens in pinball machines. So the general eject sequence it's also like a little bit simplified here, but that's something MPF does. So first, like it will check is the ball count I'm having stable. So for example, if a ball just entered the device, so it rolled into the trough, or it's actually currently rolling into the trough, then that is a very bad like point in time to eject the ball, right? Because then the last ball will hit it from the back, and at the same time you will eject, and then bad things will happen. And sometimes you will eject two balls, or the ball might also not make it out at all. So that's the first thing MPF does. It makes sure the count is stable. That means like the switches didn't change for by default 500 milliseconds. You can tune that time, but that's often a good default, right? And also like there are certain conditions which are not possible. So like in normal troughs, like the typical stern trough, there's a jam switch which is on top. I have a picture in the next slide. And then there are ball switches below it. There's like physically, there's a very, very thin chance that the jam switch can be active and there's no ball like in the other switches. That's not possible because like the ball would drop down. And that's, for example, a condition which MPF detects, and then it says, well, that looks like fishy, that trough isn't correct. And that's actually a condition which sometimes happens. Then like the balls sit between the switches and like they are like a little bit shifted, and that's something where you cannot be certain that your ball count is correct. And in that case, there are different ways. Like older stern machines, for example, they simply eject all the balls. So like Batman Dark Knight does it. It's it's super bad. It breaks your game. And yeah, basically you have to end the game because you will have like 4 balls in your shooter lane, and any ball drain will instantly end your ball. That's not fun. MPF tries to do better. So certain ball ejectors have ways to reorder balls. So like, for example, you could do like a very, very, very small pulse just to hit the balls a little bit, and typically they will roll into place then. So that's, for example, one of the things MPF does as good as it can. So have a stable count at first. Then it waits until like the target is ready. Also the same thing, it waits until the switches are stable in the target. Also there has to be space for the ball, so you should not like eject into a shooter lane when there's already a ball in the shooter lane. And there are like some other conditions. For example, if the other device just ejected a ball and it might come back, that's also bad, right? Then you might also end up with 2 balls in this device. And this also depends a little bit on how the other device is counting. So some devices are fine with that. For example, if a device only has an entrance counter, then you will be certain if a ball entered or if it returned. You can differentiate between those two. In this case, MPF would, for example, eject into the device. But for other devices which cannot like distinguish between those two, it will not. Then if those conditions are met, it will check is the jam switch active in your device. So a lot of devices got jam switches, and then there might be different eject settings because you do not want to eject both balls. And additionally, like if the eject failed before, there might also be like different settings. So like, I don't know, the ball didn't make it for 3 times, we will like increase the strength That's also what most Stern machines do on the autoplaner. If it failed a few times, it will become a little bit stronger, so that it actually makes it out. Even if it's like only a little bit dirty, or I don't know, the coil got hot, then eventually it will do it. Then, very important, MPF will wait until the ball left the device. So like, because there's like simply no chance that the ball can arrive before it left, right? MPF does not account for the time which is physical like needed to reach the other device, but it will make sure that at least it made it out. Because like if the ejector is broken, or sometimes even, I don't know, we got pinball platforms which sometimes miss pulses. I want to finger pointing here, but some pinball platforms actually have those issues. And in those cases, we will now have this failed eject state because the ball didn't make it out at all. If it made it out, then this eject timeout will run. And this eject timeout is configurable by default. It's like 10 seconds. And either this timeout passes, or like it reached the target. So the switch in the target device became active. Or if you eject to a playfield, then playfield switch became active. But for example, if there's already like a ball on the playfield, then there's no way to like confirm the ball on the playfield. Unless like all the other balls like drain, then you could be certain. But it's very rare then. In multi-ball, it's very rare. So then you typically like wait for the timeout, and if in the meantime no ball like returned to the trough, then we just confirm because of the timeout. That's the typical way how it works during multi-balls. If like the ball returned, then we retry. And like there's certain, like even retry has like certain conditions how this happens, and we will go into this like in the next slide. So, the ball device has like two main components. That's the counter and the ejector. And we will look at the counter first. So if you look like this, the typical modern trough, right, like this one, then you got often 6 or 7 positions here. So the ball drains here from the playfield, and then the balls sit here and they roll down to the coil, right? So here's eject coil, ejects the ball out here to the shooter lane on the right. And normally like balls sit here, so 1, 2, 3, 4. But sometimes like ball doesn't make it out, or it falls back, and then it sits on top of the first ball. So this is the jam position. So you often got a jam switch here. And like history showed that you need the switch. So I know that like the first spooky games, I think America's Most Haunted, they had a trough which didn't have this, and they ended up with like some kind of like ball counting issues, because like the ball would go back, and then ball search would trigger, and it will never find it, right? Because it's right in the trough. And sometimes it's hard to decide if it came back or if it just made it out really quick to the playfield, and I don't know. And that's bad. So you typically have this. But also like this ball needs, so if it's here, it needs less physical energy to get out, right? So this ball needs more kinetic energy than this one. So like with a smaller pulse, you could push this ball out. So that's important to know. The other thing is what I just mentioned earlier is sometimes the balls will sit here between the two switches, and then actually only this one is active. And I mean, you got like 4 balls, then you eject, and afterwards you got 1. And that's odd, right? So it's very unlikely that you lost 3 balls at once from this kind of trough. So that's something like the device needs to know, or like needs to figure out. And that's the job of the counter. The ball counter needs to tell like how many balls are there. And like during an eject, did the ball leave? So for example, in the beginning it says, like now we start an eject. It checks, well, those 4 are active, and now it checks if one of those becomes inactive. That would be the way how it checks that the ball left. Then it needs to decide if a ball entered, if it returned, or if it doesn't know. And like in this trough, it's tricky. It's sometimes you can tell. So if a ball drains, it typically like activates this switch first, then this, and so on. If that happens and it like rolls down, then it is likely that the ball like entered, like it actually drained from the playfield. If it just hits the gem, then it's very unlikely that this came from the playfield, right? That's very likely that the ball returned. So in those conditions we can tell, and if something else happens, so for example it drains into this position, then we cannot be certain because it can also return, push the balls back one position. So in this case we cannot tell, and then we will wait for the timeout. Because like if it returned, we are certain that it returned, then we won't wait for the timeout. Same if like a ball enters during the eject, then we will not consider this ball as like a returned ball. So that's like some heuristics we do, or the counter does, to make like this more accurate, and that's delegated to the ball counter. Yeah, in general, it has to tell is the count stable and is the device jammed. So that will be like requested from different other components. And in MPF, there are like multiple implementations. So first, there's the traditional switch counter. It's simple. I mean, count the number of switches. There's additional jam switch. That's it. Then there are also like those entrance switch counters. That's sometimes used for locks, where you just got a switch at the entrance, and then afterwards there are like 4 positions or something, and it cannot count the balls. And since the balls only enter during the game, that's also not an issue, right? Because like entrance switch counters typically got problems to find out how many balls are there if the machine starts. That's why they often got a switch on the first position and then the entrance counter, because with the first position they know if there is a ball, and then it will just eject them all. So that's like a typical combination. So that's also supported in this counter, which is used, for example, for the Gottlieb or the System 11 troughs, which got exactly that. That logic. So that's also possible. And then you can also implement custom counters. There's like an interface in MPF which you can implement, and you can have other counters. So for example, you could run a laser somewhere and count how many balls are stacked in a tube. I don't know. I think somebody wanted this a few days back in one of the chats. It's possible there. Or like you can have a scale and weight the balls. I don't know. It's possible. I mean, in general, there's an interface, and you can implement the interface, and MPF will believe you if you if you return values. I don't know if your count will be very reliable. Like in pinball, those switch counters, which with one switch per position, they have been used nearly everywhere in the last like 20 years, because that's the most reliable way, and switches aren't that expensive. But sometimes you do not have the space or something, then you can implement that. Is there anything in MPF to account for bad switches in ball troughs? Not really. So then MPF will believe either that there's never a ball, that there is a ball. And currently it doesn't account for that. So we got like some what's called like statistics, some audit statistics, and we can like generate technical alerts, but it's not that we can really handle that. I mean, if the second position in your ball trough is broken, yeah, that might work, but the problem is like if a ball drains, you will not see it. So you will not notice this drain. And then, I mean, you could emulate it with like ball like rolling down, right? So maybe, but so we initially wanted to do that, but I guess it's really hard to get this reliable. And if a ball is always on, then it will just think there's an additional ball, and it will, yeah, I mean, it will ignore it unless it's the last ball. Then the eject will fail, right? We'll try to eject the ball, but it's not really there, and then yeah, is it possible to implement a credit dot feature? Yes, that would be possible. So in 055, we implemented like the infrastructure to do this kind of stuff. And also like we already like gather those kind of events in MPF. We currently do not show it anywhere, but it's available in the service mode already, or in the service controller, which is used by the service mode. And we just need to expose it and probably gather a little bit more statistics. So like this like standard stuff. The switch didn't activate for the last 10 games or something. That kind of stuff would be relatively easy to do. So if you want to do that, we can totally help with that. So would be possible to add. And yeah, ball counters probably also know in a lot of cases if something is bogus, all right? If like the third ball in your trough is active and the first and the second is not, that's very unlikely. I mean, then you have to either you got dirt in your trough or the switch is broken. So yeah. Also like a lot of machines got like switches in their matrix which are always open or always closed. You can check if the matrix is working by checking those switches. And I think WPC also does that in a few machines. Yeah. So in addition to like ball counting or switch counters, we also got ball ejectors. And now that's basically the same trough again here. And the job of the ball ejector is to get the ball out of the device. It sounds easy. And in most cases it is. You pulse the coil and the ball will leave. It's that simple. You need some special handling for a jump ball. So as I like explained earlier, if you got a ball here that needs less energy if this ball, right? So pulse a little bit less. Otherwise, you might see that both balls make it out. So you want to have a reduced pulse time, get this ball out in this kind of drop. That's also something you can configure in MPF. And then like this reordering, so if balls are like, if switches are weird, then MPF supports like giving it a small pulse to reorder the balls. And this will like eliminate almost all the problems which you can have in stern troughs, especially if they're a little bit dirty. And I don't know why like commercial games don't do that. At least I've never seen that in any commercial game, but it really helps in my opinion. And I've also seen that happen in my machine because like there was like stuff falling in the trough. This typically resolves it. And then also like ball search, what we talked about earlier, that's the responsibility of the ejector. So it will, for example, search the ball if it can be certain that it won't like accidentally eject the ball. So normally it will just do this reorder pulse. So to make sure that if the ball is somehow stuck, it will then roll into a position and we will see it. If like there's no ball in this trough, it will do a full pulse to make sure that if the switch is broken, that the ball is out. And yeah, that's also a responsibility of the ball ejector. We got like multiple implementations in MPF. That's I think all of the ones which are in there by default. That's the pulse coil ejector. That's the standard thing, right? So you pulse the coil, the ball leaves. Next one is like enable coil ejectors. So sometimes you want to enable the coil for like, I don't know, a second or something, because like there's those typical posts which go down and then up again. Or if you got like a drop target and you just want to drop target down and up, then it's longer than just a pulse, because that would be too much energy if you give it a long pulse. Instead, there's an initial pulse and then enables for like 1 second. And that's like the enable coil ejector. Very similar to pulse ejector, but activates the coil for a longer time. Yeah, the center post that also wouldn't be like a ball device, because I mean it doesn't capture the ball and doesn't have a ball switch. It's just something which blocks the space between your flipper fingers, right? That's, I mean, because like the player can then flip the ball out with the flipper fingers, and that defeats the purpose, I guess. Yeah, like for those kind of stuff, use like coil pulses and coil player, or you can also do like custom code for that. Or we can also like have a center post device if you want. If it like does more than just enabling the coil, then that would be something which is possible. Like for example, for magnets, we also just enable the magnet, but then there's also this flinging and catching the ball and stuff like that. So it has some more logic. For that reason, we encapsulate this in like a ball, not a ball device, but in a device. And ball devices are just devices which can also like capture a ball. So you could say a magnet is a ball device. It's kind of borderline because it can capture and keep a ball, but it's also not certain. It's often not certain that it actually has the ball. So it has to capture and know that it's there. That's the rough definition of what a ball device is. I couldn't have it in. You can like hook ball search with like events. So there are like ball search starting events, and by default you can put your coil there. I don't know if we actually consider any coil which does not belong to a device. I don't think so, but you can hook it into like into a ball search event. So there's a ball search started event, and you can use that for ball search. Then there's like hold coil ejector. That's a little bit similar to enable coil ejector. That's kind of a hack. So normally you got those posts which are default up. Often you got like locks where there's one post which is default up, and you can pulse it down or you enable it down. Then one ball rolls out and it goes up again. There are like specialties for those that, for example, it depends on how many balls are in there and how long it should go down. So if there's only one ball, it needs to go down for 30 milliseconds. And if there are like 4 balls, then only 20 milliseconds. Otherwise, sometimes 2 balls make it out because of gravity. I mean, it's physics. And that's what you got. But sometimes, and especially at the moment, those posts which are default down are better available at, like, for example, Pinball Live, and you can use those as a lock. So you enable them so that they stay up. It's a little bit tricky to make sure that they do not get too hot. And then if you want to eject, you temporarily disable the coil and re-enable it. It's very similar to the enable coil ejector, but it's just inverted. And additionally, it will usually be down when there's no balls. When the first ball enters, the post goes up and stays up. That's this kind of device, which is also possible. It's not a good idea to have this like enabled for an hour or something, but if it's like a temporary lock for a few minutes, then this often is okay. Then there's like an event ejector. So this will just post an event, and then you can do whatever you want. So for example, you could use a servo and just move it to a certain location. You can hook it into custom code in a state machine, turn drop targets down for if you wanted the Denisi lock, then you can do that, for example. That's like an ejector which you can then hook. And it's very useful and very, very easy to hook into that. It's not as powerful as in code, but it works for most of the things. It works well enough, in my opinion. And then there's the mechanical eject. That's for the planger, right? So where the player ejects the ball. And this can be combined with like any other ejector, but it only really works well with the pulse ejector because that's where it actually makes sense. But you could use it with other ejectors as well. And then again, you can have custom implementations. So if you want to have like a fancy magnet ejector or a servo ejector, feel free to implement this in custom code. That's also not hard. Let me show you. So that's basically the ball device ejector here. That's the class. And they are like eject one ball. That's one method you have to implement. Reorder balls, which may not implement. Ball search, and that's it. So like those, basically those two methods. That's what the ball ejector is. And like the eject gets the eject try and how many balls are in the device and if it's jammed. And depending on those three like parameters, you can implement any logic you want, do whatever you want. So that's the whole magic how this works in code. Yeah, that's already like how ejectors work. So I hope you get the concept. Like we got counters, we got ejectors. And then we got the state tracking around it. One ball gives it to the next, one device gives it to the next device, and so on. What also can interact with it in MPF is like diverters. So if you give one device two targets, and there's like a diverter in between, then MPF will automatically control the diverter to the right direction for that eject to happen. And stuff like that works. And it can route via 20 devices to somewhere. And generally, like that's a little bit magic because you tell your game to get the ball from the plunger and then gets the ball magically from the trough into the plunger into the playfield. But you can imagine that this also works with longer chains. So if you got like some staging location somewhere, MPF can also stage balls and route them somewhere. And I do this like a lot in my head-to-head pinball machine where I got like 10 ball devices and it can route them in a circle, right? There's a trough, plunger, a feeder hole, a trough on the other side, and plunger, then again a feeder hole and the trough on the other side. So it can shoot around and it can route them where I want them to be. There's some devices which can do ball routing, but you can also like in code tell MPF route a ball here, and it will make sure that this magically happens, and if something goes wrong, that it's retried and so on. That's what MPF will do. So what should you do to get this reliable? Because like you probably can imagine now that there are a lot of failure scenarios, and that's because it's physics. And with like the limited view by looking at switches, it's sometimes hard to figure out what actually happened. But what we can do is like we can reduce the chances that this happens. That's why we got the sequence where we make sure that switches are stable and there's enough space and so on. So we reduce chances that we hit those cases which are not decidable, right? That's the goal. And there are some things you can do. So like especially in normal troughs, tune like retry pulses. So not in troughs, in a plunger. Tune your retry pulses. Make it so that it makes it to the playfield. Do not make it too strong, right? It makes no sense to put in more energy if it's not needed, and then have MPF retry it after like 2 or 3 tries if it doesn't make it. For troughs, definitely set retry order pulse. That's like a setting to give it like really a small nudge to get balls into place. That will like almost eliminate any jam conditions which you've seen before. So they will simply not appear, and you do not notice that MPF does this in the background. It will just happen, and like this eject takes a second longer, but usually you do not know that the machine is ejecting. So that really is like from an unreliable trough to a reliable trough often ways. That really makes it better. Set like jam pulse. So if it's like jammed, so if you got 2 balls stacked in troughs, make it a little bit longer and a bit slower, weaker. Sorry, a little bit shorter pulse, make it a little bit weaker, and make sure that you reliably get only 1 ball out. Sometimes what happens is that the next ball will set on top. So you you got two balls, one makes it out, the other one is then on top, and another one rolls below it. Happens. It's not bad. It's better than two balls out, right? You still got correct count. You sometimes cannot resolve that. So sometimes it will then stay this way until really you got the last ball out, and then then it will be right again. So one multi-ball later, it will be fine, for example. But this makes it reliable. And then there's something, it's called max wait milliseconds. That sounds weird here. That's part of the power supply management in MPF. So what MPF has is like it knows which it knows which coils you have and how they are connected to your power supply units. Usually by default all coils to the same power supply unit. And what happens if you pulse like two coils at the same time is that they will be weaker. So like that's for example the reason if you on older machines, if you got like those score reels, you probably have noticed that they do not turn at the same time. So they turn them sequentially. And that's not like for CPU reasons or something. That's because if you turn them all at once, they won't turn at all. So if you pulse like 10 reels at once, nothing will happen. And I know because we implemented it this way initially in MPF. And the same thing will happen if you, for example, eject two balls at the same time or even reset three drop targets at the same time. And you can manually tune that. And that's also what most WPC and Stern games do. But in MPF, we thought we can do better. And MPF will reorder pulses. So in a lot of places, you can tell this pulse can be delayed by a certain amount. I think by default in a draft that's 250 milliseconds. That's not a time which a player will notice. But it makes like the eject much more reliable, especially if you got long pulses. Consider like increasing this time, because then it will not eject at the same time as it will reset like a drop target. I mean, it's partially because I had those problems in my machine, right? Because I got like 10 devices, and if the same thing happens on both sides, that's almost always the same thing happening at the same time, ejecting at the same time. Then I often had the problems that where balls simply didn't make it to the next device, and it then has been kind of unreliable. And I mean, this can always happen, but this reduces the chances of it happening. So if you have multiple power supplies, configure those in MPF and configure max wait milliseconds also for your drop targets and for your ball devices. I mean, you cannot like control pop bumpers. It doesn't make sense to delay those. That would be weird. Slings, the same thing. Flipper fingers, same thing. That's why we do not do that in MPF. And that's the general thing, right? And I mean, if you build like own ball devices, then there's a lot more than you can that you can do. But those are like the four things which I recommend to check in MPF. And configure those if possible. And then usually you have like reliable draft, reliable whatever. It will just work, in my opinion, or my experience. Experienced pinball designer of one homebrew machine. And that's also like what I prepared. As if I timed it for an hour, I didn't, but that's what I got. So if you got any questions, anything you want to discuss, we can also look into ball search if you want. We can look into a lot of stuff. I mean, you can have multiple playfields in MPF. You can have multiple ball devices. The playfields, the framework is very like flexible in this regard, in that way. Like for standard machines, it's sometimes a little bit over the top, but also it makes it better in the standard conditions, in my opinion. And sometimes we can outperform like commercial games in ball tracking. and you explain playfield active tag and how to use it. Yeah. So what MPF does is, like, if there's no ball in your playfield, so the ball count on the playfield is 0, and MPF ejects the ball into a playfield, then this ball will be confirmed as soon as any switch on the playfield is active. And the way that MPF knows if a switch is on a playfield is by looking at this playfield active tag. And now you got like some specialities, like for example, drop target. Drop target also has a switch, and you now might want to add the switch as playfield active switch, because if the drop is shut down, then kicked down, then the playfield is active. That's correct. But the issue with that is that during ball search, when the drop target resets, it will also hit the switch. So that would then cancel ball search. And for that reason, we recommend, and I think for drop targets and ball devices, we also enforce that you do not set those switches. So in 055, we also added this for shots, and yeah, we will probably remove that again because that's kind of bad in my opinion. So shots are often also like tied to a playfield, and we automatically like mark the playfield as active. But that led to confusion because you now no longer need those tags, and also people got ran into issues because they had like shots in their modes. The mode wasn't active, but the playfield still got active, and that's I agree that this is kind of unexpected, and for that reason I'm not 100% sure, but probably we will remove it before releasing 055, and you will have to tag those switches again for shots. It's automatically done for stuff like pop bumpers, slings, drops, or ball devices. Yeah, so MPF will also complain if you tag switches in a ball device with playfield active. And that's also like the same reasons. For example, in those switches and those troughs I showed here, you can imagine that if this coil ejects, it will usually break the switch number 1. And that would then cancel ball search, even if there wasn't any ball. And for that reason, like during ball search, during the eject, the switch is actually ignored, or like all switches are ignored. And then after a few milliseconds, it will track those again. And it will generally like look until the ball is settled, because it might be also like only a random switch activation because of the coil. And sometimes we can do like better than the traditional approach, and that's the reason, for example, why you do not have to put those tags on switches in ball devices. In general, it's like it's a very good idea to have those those tags on any switch on your playfield, especially like in lane, out lane, orbit, any of those RAM switches. Because if one of those becomes active, then it's very likely that there's a ball. Yeah. Yeah, I mean, in general, like, you can have multiple playfields, and ball search is run per playfield. So you can, for example, in my machine, I got 2 playfields, but it could be also a mini playfield and a normal playfield. And MPF can also run like ball search only on one of the playfields. Because, I mean, it only lost the ball on this playfield, not on the other one. It also has heuristics to calculate for jumps between playfields. So sometimes balls jump somewhere, and between playfields you usually won't know. And there are heuristics to then play a ball transfer and make the count right again. So playfield active is I mean it's good enough. It's not always needed, right? So what you got is this eject timeout, and a playfield active switch has two reasons. So one is that we can make sure that the ball went to the playfield and then drained, and not went back from the plunger. Because if the playfield becomes active, we can be certain that it drained afterwards. Otherwise, it could make the playfield and drain. And then you would get like an implicit shoot again. So like on the old, like in the older solid state machines where this was the default behavior. I don't know if this is by accident, but maybe that's also because the logic didn't know at that point. But other than that, it will shorten the timeout before the next ball is actually ejected. And that's something which is useful for like multi-ball scenarios. So if you can confirm the ball faster, then you're faster ejecting balls, right? Because you will, I mean, with the default 10 seconds eject timeout, ejecting a 4-ball multi-ball will take like 40 seconds, and that's a lot of time. So very often you want to tune those eject timeouts just to have like a fast multi-ball. Also something which it's not improving reliability, but it makes the game more fun. But I think we added this to the documentation because like it's a common thing to wonder why it takes so long to eject multi-balls. Yeah, well, I don't know what else. Ball search. Ball search. Yeah, we can look at ball search, for example, for a little bit. So there you can configure ball search on your playfield basically. And that's like the config specification from the playfield. And there are like a few settings. So by default, ball search is not enabled. So you have to enable it. The reason for that is that we don't want to hurt people while building machines. So typically you play it with glass off, and if suddenly coils activate while you're, I don't know, fastening your pop bumpers, that can really hurt you, and we do not want that until you explicitly enabled it and want to hurt yourself. That's the reason. We recently also implemented like the stern setting at ball search. Even if you enable ball search and the machine starts up and MPF does not see any balls, then we also won't run ball search, because then it's likely that this is basically you remove the balls, you open you remove the glass, and you remove the playfield, and you just want to try something. And then we will wait until you press the start button for the first ball search, just to make sure that we don't hurt you while servicing the machine. If there's at least one ball search will run. Yeah, like that's what we do. So when the game powers up and we see one ball, then we run ball search. But we won't if there's no ball. Only if you press start. Yeah. So on start button press, it will then run the ball search. Even if ball search failed, for example, it will also restart ball search if you press the start button. That's also something which most machines do. Here you can tell it right how many runs it has per phase. So there are like 3 phases, phase 1 to 3, and it gets more aggressive. So in the beginning, it will only do like harmless stuff, and then in the second, it will also like reset drop targets which it cannot knock down, for example, and so on. And in the last phase, it will actually also eject balls if it has to. And yeah, you can tell it how often it should like run those phases. There are like a short pause after each iteration, it's 5 seconds. This is very much like modern sterns. So somebody tuned it for that. That's great. And you can also tell it like what to do when ball search failed. So there are 2 actions: either give the player a new ball or end the game. So those are your 2 options. Some games do the one, some do the other. So it's up to you what you want to configure. Then you do not want to run ball search if the player cradles the ball. You got events for that. And you can also have events to enable or disable ball search for certain reasons. And that's basically how you configure ball search. So your center post is regularly left up from an unfinished game. Need to work out how to catch that event. I mean, you can, for example, catch this ball ended event, for example, or game ended, and just disable the coil with coil player in some of your modes, or like even in your machine wide configuration. That's what I would do. But I mean, we can also like have a device for your center post if you want. Why not? And it would make sense. Auto track start. Yeah, that should work, I guess. Pulse. Okay. So yours is you pulse it once it goes up, and you pulse it a second time it goes down, or how does your center pose work? And because it's not like that it enables the coil and then you disable the coil, right? Oh, is it two? I think it's two different ones, right? One pulse. Okay. Yeah. And then okay. It's yeah. Okay. Two coils. Yeah. Then yeah. Why not? Then you could just pulse it, and you probably do not even have a switch to know where it is, right? Because you could simply only pulse the down coil to have that. I guess a motor device would work in your case. Oh, a diverter device. We got diverter devices which can have two coils for two positions. And diverters also know ball surge, so that might work. I mean, it doesn't sound too right, but that might work. Yeah, diverter actually implement the logic you got. But yeah, I mean, it also might make sense as a new device. If it's something which is available in normal machines, then why not? It usually starts small and then all the features creep into the devices. And at some point it can cook coffee and bagels and everything. So guys, thank you for joining. Has been a lot of fun. I hope you enjoyed my slideshow today, because I had no demo, nothing. I hope you learned something, and I hope you had a great weekend so far, and I'm certain you can make it an even greater weekend this evening and tomorrow and build some pinball. So guys, have a great evening, and see you next time.